Okay, so here's a polynomial function, and we want to answer all these questions here. Our x-intercepts are determined by the factors, so therefore my first x-intercept is at x squared. So that's just going to be at the origin 0, 0. And since it's an even root or even power, it's an even multiplicity, so it touches, so we circle the t. The next intercept is at 3, 0, and since it's an odd root, it crosses, and likewise with negative 4, 0. It crosses. Your y-intercept is always found by letting x equal 0. Well, if you plug 0 into this thing, your first term is 0, making everything else 0. So my y-intercept happens to also be at the origin, which we already knew that from this x-intercept right here. Our end behavior model is always going to be y equals some function. Well, if we multiply this all out, we're just going to get x to the fourth. So my end behavior model is x to the fourth, and since it's a fourth degree polynomial, the most number of turning points I can have is 3. And I already gave you the information. We are actually going to have 3 mins and maxes. So let's set up the graphing calculator to do that. So here's our function, and here's our initial graph. So notice that it looks like it's a W. We need to go down into the third and fourth quadrant. So let's just change our y min. Let's go out to 100. Hopefully that's enough. Okay, so we need to find these 2 mins and that max. So let's do the min. The first min is over here somewhere. So we scroll to the left, press enter, scroll to the right, press enter, and guess. There's our first min. Then we need a maximum, which is number 4. Looks like it's at the origin, and we know it's at the origin because it's of even multiplicity. It's x squared. But we'll just verify it by using the graphing calculator. And there's our maximum. Again, this is the calculator's way of saying that this is 0, 0. These are both really, really small numbers. And likewise, lastly, we have a minimum at there's our last minimum. So let's write that in our notes. So I'm going to write that in, and you can just see it appear. So here's our mins and maxes filled out for us. Now let's take a look at the graph, and just imagine that I drew this in on this space over here, but I thought it'd be easier for I to use a graphing program. So here's my intercepts labeled accordingly, and here's my mins and maxes labeled. The last question we need to answer is when is it increasing and when is it decreasing? So notice letter L says sketch the graph labeling all critical points. So here is a sketch of the graph with all the points labeled. Obviously you don't need to draw yours to scale like I did here, and you don't need to use grid paper. You can just sketch it, but I just did it using the computer program so it'll look a little more attractive. So the last question is when is the function increasing and decreasing? So you want to pretend that you're moving from left to right across the screen, and as you're driving your car, when is your car going downhill and when is your car going uphill? So if I imagine I'm driving my car from west coast to east coast, I'm currently going down a valley, so I'm going down, so my function is decreasing. Then my car is going uphill, so therefore my function is increasing. I'm then going down again into a valley, so my function is decreasing. And lastly, my function is increasing, going all the way up here. The idea is that at this point right here, if you notice my arrow is almost horizontal. Your car is neither going uphill or downhill, neither going east nor west. So therefore you consider at that point right there, your car is not increasing or decreasing, so therefore you would not include negative 2.853026 in your increasing or decreasing interval. So you would say you're decreasing everywhere up to but not including this x value here, and then you're increasing from B to the origin but not including those 2 x values. And you always write your increasing and decreasing intervals in terms of your x values. Even though we're talking about y values, my function values are getting smaller and smaller, my function values are getting larger and larger, smaller and smaller, and larger, my function values. However, you write your answer in terms of your x values. And notice that I'm only going to write my answers in terms of my mins and maxes. My x-intercepts have nothing to do with my function going up or down, or increasing or decreasing. So therefore my first interval, we imagine that this function goes on forever. So my x values start, my most negative x value that I have possible is negative infinity. So from negative infinity all the way to this x value, negative 2.853026, my function is decreasing. And then my function is also decreasing from 0 to 2.1030254. So therefore, those are my two decreasing intervals. My increasing intervals are from negative 2.853026, so from this x value up to 0. And then my second increasing interval is from 2.1030254 all the way out, because this domain is all reals. The largest x value I have possible is positive infinity, so it's going from this x value out to positive infinity. So let's write that answer here. So my first decreasing interval is from negative infinity to this value here. So this says I'm going from negative infinity to negative 2.853026. My function is decreasing. That's the same thing as saying x is less than negative 2.853026. These two statements are equivalent. And then my next interval, my next decreasing interval is from 0 to 2.1030254. Oh, by the way, I forgot that this is a negative. I fixed that when I paused it. So my next decreasing interval goes from the origin to this point here. So therefore, it's just from 0 to 2.103. So you can write u, which stands for or, and we want to go in between 0 and 2.1030254, which using less than or equal to is less than 0 is less than x, which is less than 2.1030254. So these two statements are equivalent. So my increasing intervals, my first one goes from this value to this one here, so from negative 2.85 to 0. And I can write that over here as, excuse me, I didn't want to do that. Negative 2.853026 is less than x is less than 0. Or, and then my next interval, this is going up over here, so 2 point blah, 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 out to positive infinity. So I'm just going to pause and write that in. So here's my next interval going from 2.103 out to positive infinity is equivalent to or this being greater than my x value being greater than that. So notice that all my answers are written in terms of the x values of my mins and maxes. I don't use the y values at all. Even though I'm talking about function values getting smaller and larger and smaller and larger, you write your answers in terms of your x values. So you write your answers in terms of going from left to right. And you want to write it from the left interval to the right interval. You wouldn't want to switch these two. So since this is the most left interval, and then this one's to the right of it, I write it in that order. Okay, that's enough of that.